Well, good morning, everyone, and thank you so much for joining us today as we're talking about empowering real-time decision-making with data streaming. So, my name is Dale Lutz. I'm one of the two co-founders of Safe Software, and I'm joined today by
Stuart Harper, and I oversee the cloud group at Safe Software, so FME Cloud, and help out on the kind of cloud endpoint connectors for the product as well.
And in days of old, Stuart and I used to go on the FME World Tour together. Do you remember those days, Stuart?
Yeah, I was just thinking about do you remember the Denver one where we like missed the train and we were running around, and yeah, that was fun.
I think there was lots of hijinks. I think, were you caught in a snowstorm with me once?
Yeah, was that Denver as well?
Yes, that's all. It's always Denver. It's always Denver. And behind the scenes today, we've got Mark Warren. Mark, you want to say hi?
Hi, everyone.
And so, Mark, you're ready there to answer questions as they pour in from the audience. And so, audience, please don't be afraid to make Mark sweat, and he can join. But as we mentioned just in the pregame chat, Mark has done a lot of the work on creating these scenarios and very knowledgeable about all this. So don't be afraid to ask him questions. And we would be remiss if we didn't mention the one who keeps us all rolling in the right direction. Stephanie, are you there to say hi?
I'm there watching the clock.
Great. So thanks, Stephanie, for all the work you do, keeping us organized and our slides beautiful and everything going well. But I think with that, Stuart, I'm going to hand it off to you to talk us through the beginning of this webinar.
Yes, so we've got this, here's the agenda, and basically we've kind of broken it. We'll do a brief recap of last week, but we're not going to spend too long on that. The bulk of this webinar is looking at FME in the context of stream processing. So Dale's got a long section at the end on building stream processing workflows, and we'll look at some use cases as well that we've seen some customers run into. But first, yeah, let's just do a quick dive into stream processing again and just recap there. So we'll start with the data. When we're talking about processing data, we need to start thinking about the data in two contexts. It's splitting that data up into bounded data and unbounded data. Now, bounded data is finite, and what we mean by that, it has a discrete beginning and end. So an example would be an organization's sales data. Maybe they're collecting the transactions every day, and every night that data is stored in a database. Once that data is stored in the database, then analysis can be run either nightly, quarterly, annually against that data. So that data has a discrete beginning and end, it's every day, and it's associated with batch processing. So you're running batch processing at quarterly and annual intervals. And then the other one is unbounded data. So this is infinite. It has no discrete beginning or end, and this is related to events in the real world traditionally. So unbounded data often comes from sensors, be it an air monitoring sensor or a GPS tracking device, or even a system that logs. That can be an unbounded data stream as well. And this is associated with stream processing. So typically FME has been very strong historically. I think 28 years now, we were saying the other day, at batch processing. But now what we're thinking about FME as it's in the context of working with these unbounded data streams. So there's a lot, if you go on the internet and Google stream processing, there's a lot of different definitions of what stream processing is. For the sakes of this webinar and when we talk about it, for us, it's a term that groups together the collection, integration, and an analysis of unbounded data. So the key thing with stream processing is here, it allows you to deliver insights across massive data sets on a continuous basis. And we'll get into the two key points there, which is massive data sets and continuous basis. So what are the two key benefits of stream processing as we see it? I think the first one is a dramatic experience for the end user and the customer. So, in today's society, we expect things to be up to date. We expect to receive notifications in near real time as things are happening, and especially if you're making decisions You know, within an organization, if you have a dashboard or you're receiving notifications that are critical to your job, you want to receive those notifications, you know, as soon after as when the event happened. And that's what stream processing gives you. And the other side of it is more and more now the data volumes are increasing and they're becoming continuous. So on one side, the customers are demanding near real-time experiences, and on the other side, on the tech side, as a system architect, you have to design a system that can handle processing all of that data and gaining insight from it nearly instantly. And to do this, you need a framework for analyzing the data in memory before you store it to disk. Storing the data to a database and then performing the analysis, it's too slow in this kind of batch processing world. So we've already kind of alluded to some of these challenges. We've got very high data volumes. Sensors, if you have sensors logging from, say, vehicles or rolling stock on train or in a factory from equipment, data volumes can be very high. Also, you have to deal with inconsistencies between busy and quiet periods. For example, if you're tracking vehicles at 3 o'clock in the morning, you're going to have very different vehicle volumes to during rush hour at 9 a.m. So how can you build a system that can be responsive to that inconsistency? And again, data can arrive out of sequence. If you've got hundreds of sensors reporting, some of these sensors, the internet might go down on them and they might have to switch to another network, or a switch might go down. So this data might arrive out of sequence. And then another challenge is a lot of the open source world and many solutions, you need to still write costly custom code to design and build these solutions. So stream processing, it means better business insights. There's no doubt about that. But no code data integration really makes stream processing accessible for all industries. And that's what we're going to really dive into now.
So if you think about FME, which is our product that we've been making for almost 28 years now, it sits in this world between all different kinds of data types. So we like to say that FME is a tool that loves to deal with spatial data, but it also doesn't mind dealing with attribute data too. So you can see from this diagram, there's of course CAD and GIS and databases and cloud applications, but sensor data actually plays a role in our universe. FME is today what we call a full integration platform. And we like to say you connect to things, you transform them, and then you automate the whole thing. And those words apply whether we're dealing with files on disk, database tables, or streaming data sets. We begin our work over on something we call FME Desktop, where we use a graphical environment to author and build workflows, and we can even run them there and test them. And sometimes if we're just doing things ad hoc, that's the only place we use them. But if you need them to be run in a kind of a controlled environment, then we can pop them up to FME Server. FME Server can be installed locally on your own IT infrastructure, or it can be out in the cloud where you've bought the license, or you can pay us by the hour and we host it for you in something we call FME Cloud. But in all those cases, FME Server looks after the management of running these transformations. Often they're run in response to a trigger or something happens in the universe and we wake up, do some work and shut down. But in the case of streaming, we started going and basically let it run forever and it does its thing. Lastly, we do have some mobile apps so you can look at data in virtual reality or augmented reality through FME AR, or run FME Server applications to deliver data to your mobile app if that's what you want to do.
So now we'll take a look at kind of more specific into the components of the FME platform. But first, I just kind of want to give you an overview of what the whole FME platform provides as a whole. So the first thing, if we think back to some of those challenges we had, the first thing is, FME allows you, because we have this new engine running in stream mode, you can do really high volumes of data with really low latency. So that's really powerful for stream processing because each engine can process thousands of points every couple of seconds. It's also scalable. So if you're a large organization with extremely high demands, you can scale up very, very easily. But if you're a smaller org, then you can just leverage one engine. Now, one of the most exciting things I think is our platform is it's not only a no-code solution, but we also have all of the support for handling spatial data and doing spatial analysis. And this is so important in the world we live in now, because almost every sensor out there has the capacity to take location in. So this could be a GPS device, but increasingly, even indoors now, we're tracking location. And even sensors in like a factory or something like that, they all have location tied to them as well. Granted, it's static, but there is an element of location. And the other thing FME provides is, we talked about, these streams, some of the times it's extremely busy and other times it's quiet. You don't want to be paying for capacity either in the infrastructure or the licensing when you're quiet. You only want to be paying when the data comes in, and FME gives you that as well. So that's kind of the FME desktop world. Dale's going to go really deep on that in a second, but I just wanted to kind of introduce FME server, because we can do FME stream processing on FME server, and many customers have done it in the past. So I just kind of want to show you where we are and just segment things a little bit. So the first one, batch processing of stored data. So we've been able to do this for as long as we've had FME server. So this is about storing that unbounded data into a database before you process it, and then doing batch processing on this. So, we've seen a lot of success here. And if you just click there once, Dale, I think, so this is FME server schedules gives us this. So you can publish your workspace, and then you can batch run every hour, every minute, whatever you want. But the problem with this is, it's not real time, and you can't handle really high volumes because the engine has to come up and down. So the next thing we have is event processing and FME server automations. So this is automated in that you don't have to schedule a process to run, it's event driven. But with event processing, it's very, very good platform for handling lower volumes. So if you have a message coming in every minute or every 5 minutes or even every 30 seconds, FME server automations is really powerful model, because every event can trigger a complex workflow to do analysis on multiple workspaces. But each time this event comes in, the workspace starts up, the workspace starts up, the engine runs the job, and it shuts down. So it's got a lot of overhead associated with it. So what we're really going to focus on today is stream processing. So this is a new feature on FME server, and this is all about the continuous processing of high volume data streams. So you can see we've got all of these 3 different scenarios now covering basically everything you'd want to do with stream processing.
Mm-hmm.
And Dale's going to show you this in a second, but this is the new FME server streams interface in FME server 2021. And this lets you set up, scale, and monitor stream processing workflows. And I think we'll just leave that at that for now. So the other thing is, okay, so we can run an engine, we call it, in stream mode, and it can handle a huge amounts of features. But the other piece of the puzzle, which you have to code manually in lots of other systems, is how do I connect to my endpoints? How do I connect to my sensors and my messaging queues? Well, I showed you this slide last week, which kind of shows the ecosystem of brokers out there. And if we see now, we can see if we can see what FME supports here. So all of the green squares here are what FME supports. So you can see we have extremely good coverage, and this is reading and writing too. We've got MQTT, AMQP, Kafka. It's more what we don't have than what we do have, to be honest. And it is a complex ecosystem out there, so we're not saying we have everything, but if we don't support it, then come and talk to us, and we'll see what we can do. The other side of things here is when we talk about stream processing, yes, you can do this on premises. Yes, you can build a system on premises, but more and more, when we're talking about these large data volumes, you need things like data warehouses, data lakes, cloud storage, scalable databases. And with FME, we support not only all the relational databases, but all the data warehouses, data lakes, and cloud storage as well. So you can really write that sensor data to any endpoint.
So at this point, we're going to involve a little bit of audience participation. So if you feel comfortable, chime in the chat and let us know how you use streaming within your organization. If you use it, if it's coming in the future, what the scenarios would be, and what just anything about what your plans are. And if it's not something you're doing and you're just here to learn more, that's totally great too. Please let us know that. And while you're busy typing in, I'm also really curious, how much expertise or experience do you have with FME, or would you say you're new and you're pretty not familiar with it, all the way to you've been using it for 28 years and you're an expert? So we'd love to know a little bit more about all of you. So please do chime in and let us know. So in terms of some of the common use cases that we're seeing, I'll just, in the talk last week went into these in much more detail, but there are a whole host of families of these. And the one that's kind of the easiest to wrap our minds around is just tracking of mobile assets. And we'll do some demos around that. But we've seen customers look at sensor data so they can schedule and take maintenance action to prevent failures. And then, of course, other things around smart metering, supply chain management, and network analysis. And I was just looking at some dashboards of the vaccine rollout in Canada and thinking to myself, wow, that seems like that could be tracked in a bit better way. There was one official government site that I saw was basically being updated once a week, which I thought seemed a little bit on the slow side, Stuart. But yeah. But anyway, that's the kind of thing that eventually you would hope would get a little bit more up to the minute kind of action. And I'm in Canada, so that's maybe I'm picking on my poor Canadian government, but anyway. In terms of customers that have been doing this kind of thing with FME, even before we had the most recent capabilities, one of the poster children is the Iowa Department of Transportation, who built this system where FME sits in the middle and ferries data between lots of different places, but it ultimately allows them to present to their citizens where the snowplows are on the roads in the whole of the state. And you can see imagery from each one, and you can figure out what the road conditions are. So it actually is really an amazing, wonderful site, and a lot of real-time data flying around between a lot of systems. We've done talks on this before, they have as well, and it's pretty amazing. And I just love David's quote for us that FME is the cherry on top of an ice cream sundae, which makes me a little hungry. I haven't had breakfast yet, Stuart, and I feel like a good ice cream sundae could go down well right away here.
David's great.
Another one that we have talked about for years are the Pelmorex folks who are behind a weather network up here in Canada. And I think it's more than just in Canada, but they were building a system to track lightning strikes. And I remember when we were testing this, I was astonished how often lightning does strike a big place like Canada. And they were able to use FME in an early form of this stream processing to do some spatial analysis on this data on the way by, to do actually event notification or event creation, really. And of course, ArcGIS was part of it, and other kinds of things. It was a fairly amazing, great system. And so I think, Stuart, I'll ask you to just give us the intro as to how this all hangs together.
Yeah, this is a great section. So we're really going to start diving now into the FME platform and how we build stream processing workflows. So the first step here is building and authoring the workflow in FME. So there's nothing different here. For those that have been using FME platform for years, we're going to open FME desktop and we're going to build our workflow in there just as normal. So the first thing we need to do is connect to our stream source. So here, we can go to Kafka, MQTT, any of these endpoints. Once you've done that, you need to decode the stream message. So typically we see clients bringing in JSON or XML, but anything, some weird file formats, there's like CAT format with the column aligned text, or CSV. Any of these formats we can read and transform. And then once you've brought this data in, you're going to apply the filter in the processing. And this is really where the power of FME comes in. I think we have, 400 plus transformers now, probably. And so you can do complex spatial analysis, or you can do just simple filtering. And then once you've done all of that, you can write the data to a data store. And the key thing here is you're reading the data from Kafka and you're writing the data out to an endpoint, and it's all in memory. So you might be reading 100,000 points a minute in memory from the sensor, doing all of the analysis, and then writing that out and storing it in memory. And once you've built your workflow and authored your workflow, that's when you publish it up to FME server. So you can see here, and Dale will step through this in a minute, but what you're effectively doing when you publish this workflow to FME server and create a stream, you're saying, I'm going to assign these engines to this stream, and you can do one or more engines, and these engines are dedicated to this stream. That's all they're going to do. And when this stream starts, the workspace comes up and it runs in stream mode. And what that means is the workspace is going to run indefinitely, and it's going to kind of lock on to the endpoint, be it Kafka or wherever you're connecting to. And it's going to create kind of an open socket between those two endpoints. And that's where you get the high volume and the low latency from.
Mm-hmm. Well, Stuart, is it time for us to roll up the sleeves and start showing some stuff?
Let's get going, yeah.
Okay, so we've got 3 scenarios we want to walk through, and one bonus one if we have time at the end, where we're going to actually start looking at this stuff in action. And there's a lot of moving parts, and it's going to be a bit exciting because we're going to really try to show you this stuff working. And Elon Musk has said that we all are living in a simulation, and maybe today we're going to have a simulation within the simulation. So for all of these cases, I'll just mention that Stuart, you generated some data a couple of years ago, right?
Yeah, it's very, very hard to find real-time streams for free because they're quite expensive to maintain. So yeah, we've just simulated basically vehicles moving in Vancouver during a 3-hour period.
Yes, and so behind the scenes, the wizard behind the curtain is my friend Stuart, who will be starting and stopping that simulation for me. And from your perspective, as you watch, you just need to believe that there's this magical supply of data arriving in a Kafka service somewhere. Is it hosted, Stuart, by somebody?
Yeah, it's hosted by Confluent on the cloud, so it's a cloud SaaS service.
Yes, so Stuart is going to be running, basically simulating some vehicles, loading it up into there, and I'm going to be attaching to it and hopefully performing some magic. And today we've chosen as our output for these scenarios, we're going to be looking at stuff inside of PostGIS, which probably wouldn't be the real database that you'd use if you really were saving things from a streaming, but it's just convenient for us. We've got a PostGIS hosted up in Amazon, but you could write to files, and at the end I'll show you an example like that if you were going to put them up to a data lake or something, or you could just be writing into some of those big cloud databases that were on that slide of Stuart's, like BigQuery or Snowflake or others. All of those things would work. But in this scenario here that we're gonna walk through, a pretty simple basic one, we just want to save the locations of trucks. So we've got vehicles zipping around all over Vancouver, but there's, I don't know what all you're simulating, Stuart, but there's little vehicles, big vehicles, cars, sedans, SUVs, but in that mix are some trucks. And so we're going to throw away everything else because for our application, we only care about where the trucks are. And this is the Vancouver truck fleet. Isn't it an impressive one, Stuart?
Yeah, lovely.
They don't mess around in Vancouver with their trucks.
Green trucks.
Yes, they're very green. So the generic streaming pattern, if you look up on our tutorials we're going to give you afterwards, we have a variety of patterns that we walk through. And this is one of the more simple ones where we're just filtering by the value of an attribute. So we got lots of data coming in. The magic funnel arrives. In this case, it's going to be FME with its tester or test filter, and then the filtered data gets saved out. And we've reduced data volume. So we just didn't save it because we don't care about it. So that we're reducing our costs in this way. And so how are we going to do this? What's our approach? Well, much as Stuart introduced there, we're first going to connect to the stream source. So here today, we're going to use the Kafka connector, which will connect and read till eternity. Then it gives us back a JSON JavaScript object notation payload, and we're going to blow that up into record attributes. So there's a few things in there in our simulation. Location is one of the things as a bit of well-known text, and we've got also a vehicle ID and a type and so on. So the JSON flattener takes that JSON apart and gives me individual columns or attributes I can work with. Now we do our testing to select those we want, separate the sheep from the goats. And lastly, we're going to write stuff to our data store. And in our case today, we're going to be writing to PostGIS. And here's where you got to be careful, because data won't actually be written to PostGIS until the commit interval or transaction or features per transaction are hit. So we will adjust our commit intervals so that we're writing often. And if we weren't using a database and we're going to a file or something else, we might want to use this FME thing called a feature writer to give us greater control. And we'll look at that at the very end. So that's the general approach. And so I am now going to go and using techniques that my friend Jen has taught me, I'm going to write this workspace in front of your very eyes. So here we have a nice blank workspace. I'm in FME Workbench. I'm ready to do things. And normally I would type on the canvas like let's get going with a creator or something, but I don't need to do that today because I can just hit the magic undo, and magically I'm going to now create one record. This creator is making one thing that's going to get us going. And we need that because we need to give our friend the Kafka connector a kick. So this is the next transformer that Stuart configured for me ahead of time. There's our secret password. Do you even know what it is, Stuart?
Oh, it's about 40 characters long now. Yeah.
Anyway, somebody knew it once, maybe Mark does. And this is this Kafka service that Stuart has over on AWS set up. And there's a lot of things that I can do with this Kafka thing. I could actually also send data to Kafka if I wanted to. So I could use FME to read Kafka and write to Kafka as a sort of a filter in there. And the big key thing here is I'm in stream mode, which means when this starts running, it's going to stay running forever. And I will point out that you can run this thing in what's called batch mode. And if I do that, then I can say, just give me 200 records and stop. And when we're testing this and developing, that's what we often do. But today I'm going to be in stream mode. So now I've got data coming from Kafka. I've woken it up with a kick from the creator, and now it's going. And now I'm doing that JSON flattening that I spoke of. And in here, I just say the JSON document that came from value out of the Kafka connector, that was the whole JSON payload. And I'm getting it to blow things up. And here I've listed the columns or attributes that I know are going to be there. So there's timestamps with this data. There's a vehicle ID and a category and a type, and geo was well-known text. So next, I filter out the trucks, and I do this with a test filter, and I basically just say, when the vehicle type is trucks, we're going to route that to trucks, and the other stuff I don't care about, so I'm going to route it over there. Now I go and make geometry. That's the spatial business that we can do. And I do this with something called an FME geometry replacer. And I'm decoding that well-known text that was in there that had a latitude and longitude. And that's going to give me a point now. And then lastly, on the geometry side, I make sure that everybody knows that this is in lat long 84. So that's a little bit of spatial stuff. And now we're in good shape there. So I've got my data coming through. I've filtered out what I want. It must be time to save it to PostGIS. And so here I have a PostGIS writer, and it's ready to go. And I'm saving only the vehicle ID, the timestamp, and the vehicle category. And over here in the PostGIS writer, if I open this up and I look at the advanced settings and look, I see that I'm committing every 100 features. So every time I get 100, I'm going to write them to the database. Your mileage may vary. In production, you probably wouldn't want that often, but for demos, I want to do this. And so I think maybe it's time to publish this up to FME server. I believe that this is going to run because I've tested it before. Normally you would test it locally, but I'm going to go ahead and publish this to FME server. And here's an FME cloud instance that it looks like Stuart made for me. So thank you, Stuart. And I've got my connection ready to go. and I'm going to upload it into this thing called Trucks Please. Yes, I'll replace the one that was there because I'm confident. I'll send it up my connection to my database, and I'll also send it the instructions to get to Kafka. And now we're going to do this publishing, and it's uploading pieces and sending our configuration up there to server. And now we're in good shape. And I'm going to hop over now to my FME server, which is sitting here ready to go. And if I look inside of that streaming repository, I see that I've just put this up at 8:31 Vancouver time, which is right. And so we are in business. And so now we go and visit the new functionality that's part of FME 2021. Besides the fancy, nice blue background and design, which I love deeply, I can go into the streams area and say that I want to build a stream. So I'm going to call this stream trucks only. That's pretty inventive. And I'm going to go to the streaming repository, and there is only one thing in there. And so it's giving that to me, and that all looks good. And I have now built a stream. But Stuart, I think nothing's happening yet, right?
Right, so this is the thing. So you're going to start the stream, but you still need to make the decision when you assign the engine. And so if you assign an engine here, you can assign one or more engines to the stream. And once you do that, as soon as you assign those engines, they're dedicated to that stream. So it's gonna remove the engines from the pool from other processes, and it's completely assigned to this stream. So we only need one engine in this demo.
So the little engine that could, I'm going to assign it, and it's going to go, and it should start running. I should see a little gear here if I'm lucky. Oh, it's queued. Is that a good sign, Stuart, or a bad sign?
Give it a second, and it should.
Okay, I was nervous.
Takes about, I think we look every 3 seconds or something. So.
Okay, I managed to have the maximal amount there just for added dramatic effect. And so now this thing is grinding, and if I want to see if I believe, I can click on it, and I will see the thing that we love so much at FME or at Safe Software, and that is the log file. And here it is running. Is that right, Stuart?
Yeah, and so we should start to see, you can see here it's connected to Kafka, and then we should start to see it pulling those features.
Okay, lots of scary things from Kafka coming. It's got to kind of wake up and get connected. And oh, there we go. We've had 100 go by. And so now this thing is off and running. And if I want to go look, I use my favorite PostGIS viewer, and that would be the FME Data Inspector. Of course, there's other ones you could be using. PG Admin, I know Stuart's a fan of, but I'm going to look and see what we got in the truck locations just to see what's coming in. And so we're busy loading our data. We're connecting to post. Okay, we have 300 by now. So here they come. And there we have a bunch of locations in Vancouver. And I bet if I refresh this, we should start to see some more. And there we go. And I'll refresh this. And by now, I bet there's going to be, what do you think, 500, 600?
Yeah, maybe 500, yeah.
There we go. Yep. And so you get the idea. We are storing this data, and it's looking good. And we've got ourselves our truck locations, and with all of their attributes and their timestamps of when they were there. And so that's our example, and it all was working, and we could leave this run until eternity. But I think I'm going to stop this now, Stuart, just because why would we want to poison our demos coming later? So I'm going to go to this thing. Let's see. If I go to this one here, click on it, I can go up here and say stop, right?
Right, and so if you stop the stream, then the engine will stop and it will stop running, but the engine's still taken from the pool. So the engine's still assigned to this stream, but it's just not running the job anymore.
So if I really wanted to be a good citizen, I would actually unassign it with this button here.
Right, and then that releases the engine back into the pool, and other users can use that. And of course, one thing I would say is in most circumstances, it really makes sense to use dynamic engines when you're running a stream.
Yes.
Because then you only pay for the compute you're using. So if no data is coming in on the stream, then you won't drain any credits. If data starts coming in, then you'll use credits. So that's a really great scenario for the dynamic engines as well.
Yes, and so dynamic engines is a new additional business model we've got for people that are doing streaming or other kinds of bursty kinds of workflows where they only pay for the CPU they use. And I'm going to stop here for a second, Stuart, because I see our friend Carl has noted a little bit of sleight of hand there that was that went on. It's unfortunate. When I walked through that publishing wizard inside of Workbench. So I'm going to just go through that because it is worth pointing out. So I went File, Publish, and I said, sure, we'll continue. And I did all these things. Yes, sure, continue, continue. What's with data streaming here, Stuart? And what is that about? And why didn't I click that one?
Right, so data streaming is, I think, how many years must this have been? This was kind of launched with the original FME server, and this is about streaming data out.
Yes.
So this is about turning a workspace, be it like JSON or XML, some kind of text endpoint. And what it means is whenever the end user runs the workspace, it produces the actual file as the output.
Yes.
So would we call it data streaming now? Probably not.
No. And yeah, so basically it's an old word for an old use case that's still valid, but we almost need another checkbox here that would let me say, stream processing or something like that, just to make it clear that it's a different thing. Because yes, job submitter is just kind of the generic service. So anyway, thanks, Carl, for pointing that out. And that is a key thing to be aware of. So let's hop back to our slides. We did all these things. This was the workspace. And yep, you saw it, and we went all the way through it, and we saw the results. So that's kind of nice. So yeah, just to review, we were connecting to a stream with Kafka in stream mode. That's the key magic there. And then we published it to FME server and created the stream, and off it ran. And again, Stuart, do you want to just chime in on this? This is what it would look like, I guess, if you had something that was needing much processing power.
Yeah, so imagine if you created a workflow in desktop and you run the workflow and you've got 1,000 messages every 10 seconds coming in. And when you run the filtering workflow in Workbench, you can only process about 300 messages every 10 seconds. So what you can do then is you simply scale up the engine on FME server on the streams product to handle the increased load. And so you can keep adding more and more capacity to do the filtering per stream.
Yes, and the beautiful thing is that Kafka connector is very cooperative with its friends. So if you have 4 workspaces running at the same time, all using a Kafka connector, the Kafka protocols underneath make sure that any message only goes to one of them. And once a message is consumed, another person won't get the same one. So that's how the magic is allowed to happen. Someone has asked, and I'm going to just go back to this, why the heck do I need this creator transformer? And I need it because this Kafka connector won't do anything unless something arrives to give it a kick. So it is not, the Kafka connector isn't a reader in FME land where it will just start going. And the reason it's like this is because the Kafka connector can be set into send mode. And if it was in send mode, then the data that's coming in would all be sent out to Kafka. So lots of records would be expected to come in. When we're in receive mode, we really just need one dummy record to give it a kick to tell it to wake up, and then it will do its thing. So anyway, I hope that helps with that. You'll see that pattern actually in lots of FME things that use connectors. Okay, so scenario 2, every 30 seconds is enough. So in this case, again, we have all the vehicle locations being streamed, but we don't really want to save everything. We only want, in this case, every 30 seconds being good enough. So we're going to save that to the data store when that happens. And so the generic pattern is we are going to break the unbounded stream into specific time windows, in this case, every 30 seconds. And then we're going to do some processing in that window, i.e. take the last one only. And we do this by using this new transformer called the time windower. So this thing lets you set a duration for a window, and then we give you a window ID that you can use downstream. And these IDs can be a sequential number like 1, 2, 3, 4 all the way up, or they can be they can be a timestamp which is in seconds since 1970 or some crazy thing like that. And then you can actually have real times with them. So either one of those. And there's settings in here whether or not the data itself has a timestamp or you're using the current time. You can also indicate where you want the windows to start. And we go through this in more detail in our tutorials, but it's a very, very powerful transformer. I will add that we are continually tweaking it and adding it. And with time, there may be something called a grace period so that a latecomer that should be in the previous window will get the right identification. That adds complexity, but there is sometimes when data doesn't quite arrive in sequence, and we are going to be on that too. Now, here's where the FME magic starts to happen. Once we have our data tagged with its window ID, we know that all the data in our stream is going to have the same window ID until the window ID bumps up, and then we will get a new batch. And in our group bys in FME, we have this kind of a toggle. We say group by the window ID, and then here's the thing. We say process the data when the group changes. If we have it in the other one, process at end, there never is an end in these continuous workflows. So this when group changes is so important. So here I'm sorting the data for a particular window ID, a particular time block, first by vehicle. So all of vehicle 1 readings will come before vehicle 2. And then within vehicle 1, I'm going to go from the oldest to the newest within that time window. So I've added some order to the data within the time window I'm working on. And again, the process when group changes is so important. And secondly, I need to use, in my case here, the sampler to say whenever the window ID and the vehicle ID change, then we know we're done the group, because the sampler is going to come after the sorter. So we know the data coming into the sampler, all is going to have the same window ID for a block. And then within that window ID, we've sorted it so the vehicles are coming contiguously. And we're going to say take the last one, and that's how we get our last reading. And so here's the workspace, and I'm going to go out here and give this one a spin. So this is every 30 seconds. And I think, Stuart, we're just going to go ahead and run this thing locally. So I'm not going to try to publish this one up just for time savings. And with luck, the simulation is simulating, and we've started it. So you can see that our creator kicked off the Kafka reader, and it said, yes, I'm going. And now this thing is waiting forever for data. And oh, stuff just happened. We got 30 readings just now, and they are going into the time windower, and they're now piled up in the sorter, waiting for the time window to change. And we said every 30 seconds, so we have to kind of idly fill our time here until more things happen. So lots of data is coming through, but we're not getting to the next.
So someone asked, could you run this functionality in a desktop, or do you need server as well? I think that's a good question.
Well, we're running it right now in the desktop, but now I'm kind of using up my desktop forever to do it. So you can certainly do it for testing or for small amounts of things. But if somebody reboots my computer, it would shut down and it wouldn't start again. We didn't actually say that, Stuart, but if on FME server, when you're in stream mode, if anything bad happens, we will start that up again and keep going. Whereas in desktop, you wouldn't be. So yeah, we're doing it. You can see we're getting this nice thing. We sorted 622 features in group 2, and the sorter is going to keep on going and giving us this nice little answer forever. And we are, you can see, throwing away piles of data. So I've saved 119. I've thrown away 745 so far. And this thing will just keep on going. And Stuart, I'm just going to hop over to my favorite inspection tool here, and I'm going to try to open this. Let's see, we'll go back to PostGIS, and I don't want truck locations. I saved ahead of time the vehicles, which is the nice table here, and we'll just go ahead and read the vehicles, and I'd expect there's maybe at most 200 in here by now. We'll see. Yep, 200. Lucky guess.
So they should be thinned out a bit more, I guess, now, a bit further apart.
You can see that they're not super tight to each other like they were before up here at UBC. If I turn off the map, you can see this probably. Yeah, there they are. All these trucks driving around UBC today, or at least whenever the simulation was simulating. So anyway, you can see it's going, and we're just throwing away a whole bunch of data, and the whole machine works so wonderfully. So I think I will stop that there and end it, and kaboom, we've now ended this one, and that simulation is over. All right. So that's what it looked like. Again, we were whipping through the Kafka connector. That whole business at the beginning was the same. And then this bit of magic, assigning windows, sorting, and then taking only the last. So, yep, time window assigns the block, time window block ID. And then we use the combo of sorter and sampler so we can get the last. And yeah, works well. So these two have been fairly straightforward patterns, a little bit of interesting building of concepts, but now we're going to go to danger, Will Robinson. What if there's troubles? And Stuart tells me that some of his trucks in his simulation are carrying plutonium. Is that right, Stuart?
Yeah, that's right.
I think Vancouver is nuclear free, so that wouldn't be possible. They might be carrying, let's see, I don't know.
This is actually a thing, though, is maybe not the schools to hazardous materials, but alerting organisations or people when there are vehicles with hazardous materials on them that come into areas they shouldn't be. So
yes, exactly. So what we want to do here, and of course you could apply this pattern to your own universes, but we're going to be reading the unbounded stream. We're going to have some buffers around our schools. We're going to use some spatial processing that's very natural to FME, and then we're going to do some kind of alerting if something happens. And I bet the simulation is beginning already. And so we're going to go and look at this workspace here. So there we go. Let's see, too close for comfort. Once again, it's the same beginning of the workspace before our Kafka streaming stuff, but here's where the filtering happens. And I'm going to actually just test some stuff first. I'm going to read the schools only. This is using FME's run to here capability. So I just read the schools, and down here I have a map of them in Vancouver. And what I'm doing is for each school, I'm creating a buffer of either 100, 200 or 300 around it. And I'm going to run all the way to the bufferer so we can just take a look visually. There you can see these nice, boy, it looks like curling, doesn't it, Stuart?
Yeah.
I saw that. I think in Canada we are curling, so at least the Canucks might be benched, but at least we can watch curling. So we're excited about that. I saw people when I walk around town in the evenings, I can see people's TVs through their window. Not that I'm a peeping kind of person, but it's hard not to notice these circles projecting on people's windows at night. So anyway, this is the kind of data we're going to have, and we're going to send that in to the spatial filter. And I'm going to get this running now. So let's rerun this whole workspace from scratch. And again, my buffers all go, and the spatial filter is loaded up. And now Mr. Kafka is waking up. And I had to, one thing that got Stuart and this creator, I needed to tell this creator a very technical thing, create at the end, which means after all the readers are done, then create this. Because if I create this at the beginning, I will never read the schools and I will never get anywhere. So the schools finished reading, then I created this, Kafka connector woke up. It's now pumping data out. And we have gotten ourselves about 66 readings of our hazardous trucks. And we're now up to 72. Whoops. And now I want to just talk about what's going to happen here. If we ever do find one, the order that they arrived within the spatial filter is going to be the order that it will match. So the first match that we get will be what comes out of the past. And I will also mention another trick here. If we slide over to this schools, I have these records going to 3 places. So I'm making 3 copies. One goes to 100, one goes to 200, one goes to 300. I really want the one with 100 to enter the filter first, the one that's closest, because that one would be where I want the point to match. And I ensure that by setting connection orders. So the schools record goes first, a copy goes to the creator, then 2, then 3. And that's an important thing in these streaming ones, is knowing the order of the features, which will go shooting through until they stop wherever they were going to go. And so now I'm up to 106 records. Once I ever get a match, I'm going to go into a time windower because I only want to send an alert once per minute. In this case, I've set the time windower up. So give me one every minute if anything ever comes through here. And now what I want to do is I use a global variable in FME for each vehicle ID. And I say, if I get something coming through, then I will remember its ID will hold the window for that vehicle. And I'll check, is the window different now than what it last was for this vehicle? The first time through it's blank, so it won't matter. And the second time through it will. So you can see that it's working. Oh, and then lastly, I set this variable so that the vehicle knows the window ID that it actually was alerted for. So I can see here that I've had 12 events that were close, but I thinned them out to just 2 alerts because I don't want to keep hassling. And lastly, I've gone here into my test filter and I have different kinds of alerts based on how close we were. So 300 meters, I'm going to send me an email. 200 meters, I'd go to Slack. 100 meters, I'm going to send Stuart an SMS using a Twilio caller. And so this says I've sent 2 emails so far. Oh, now 3. So I should go check my very private email account here, the FME Meister. Oop, that's a bad sign. Yes, proximity alert. So we see here that the vehicle has gotten close to Lord Kitchener. So that's pretty exciting, and it is busy running. So is that enough drama for you, Stuart?
Oh yeah, and you could have even sent nice fancy HTML emails as well, couldn't you, to really surprise them when they opened it?
Yes, we can include a little map tile. It would be exciting. That's been done before. I did the wimpiest one ever, but you can make Trello cards every time this happens. You could do all kinds of stuff. And anyway, that's lots of fun. So I'm going to just probably kill that, but that gives you the sense of all that. So that is this more complex example that we had going. So again, using the time windower here as a post process just to thin out the number of alerts I was going to be sending, the real processing happening with the spatial filter.
I like this one because you're merging a stream and a static data set, aren't you? Which is actually quite a hard thing to do.
Yes, that's a very good point. I didn't really say that, but here's the schools data set, doesn't change. We load it up at the beginning and it stays there for days and days and days doing its work as being a bunch of filters. So so that's what we got there. So the creation reader order, yes, I talked about this a little bit. When you have several creators, you can set their order, the order that they are at the end or at the beginning. All of that needs to be kept in mind when you're using streaming in that fashion. And the junction order we looked at as well, so that you may need to be sure you're sending data to one place before it goes to another with that connection order. That's always been in FME, and most of the time, almost all the time, you don't care, but in streaming scenarios, you sometimes would care. So again, what was the recap? We were merging static data with filtered data. The spatial filter is finding us records of interest. Longtime FMEers will be pleased to know that the spatial filter in FME 2021 is drastically faster than it ever was before, so we put work in there. The buffered features arrived from the smallest to the largest, and we also used a trick with the global variables to set a state that we can retrieve later. That's another trick in our toolbox for dealing with data that's streaming by. This idea of putting a value somewhere. I made a variable that was for each vehicle ID in the memory of FME, and then I can read that back and check if things changed. And lastly, I used a handful of different connectors to send alerts, and there's other ones that we've got as well. I mean, you could also write to a database and use database processing downstream, or send it to a different Kafka stream even. There's all kinds of things that could happen in that case. So as we wrap up here in the last 5 minutes, just thinking about some advanced workflows that are possible. If you want to write out files, you can use a feature writer transformer in FME, and you tell that feature writer to group by the window ID and to process when the group changes. So when the window ID changes, we will shut down and close the old writer completely and start a brand new one. Now, if you're writing a file, you darn well better be writing a different file each time, otherwise you're just going to erase yourself. And so that means that either the data set or the file name need to be changing each time that window ID changes. And in this case for CSV, we would just say that we'll make a new file with the suffix of the window ID. And you can use a function of the window ID as well, which I'll show in a second. Stuart doesn't know I'm going to do this, but I've got a couple minutes. I'm going to haul out one of our old simulations. This is now a simulation of a simulation of a simulation inside here. But this was one that Stuart and I put together when we began our work as far as thinking about how to get FME to work in these cases. So here, this was before we had Kafka going or anything else. I'm just using a creator in FME to make myself 2,000 points in lat long. And then I'm offsetting them to put them into Vancouver. Offsetting them randomly. Then I'm slowing them down so that they're 1 point every 100th of a second, just to give it something to look at. And then I'm putting them into Vancouver with this one. There's two offsets, a random. I could do this in one if I was more fancy. But now I've got a whole pile of points. Now I'm going into a time windower that says every 10 seconds we're going to make a new window. And here's the magic. I'm getting a dynamic clipper. Every time the window changes, I'm going to go out to a database and get my Uber drivers locations to see which points are near the drivers at that time. And this is basically selecting bounding boxes. And so I'm changing the clippers every time. So the window changed fires before the data comes out. I'm going to go ahead and run this thing. And so we're going to generate ourselves 2,000 points. We're going to go out to the SQL database, get ourselves a clipper. And then when the window changes, hopefully in 10 seconds here, yes, the second one came through, and now we've had 4 features go in as clippers. So we're basically pulling from the database each time that the window changes. And in this case, I was going to get stats for each driver. So I'm sorting within each window by the driver's name, and then I'm going to calculate statistics as to how many points were in that driver's area. And then I use this fancy date converter here, so I can actually look at this because it's finished, and I can see that Don and Dale were the drivers. Looks like we picked up new jobs, and I can find out some stats about each of us. And these window IDs were kind of these seconds since 1970, which is sort of annoying. So instead, I use the date time converter to flip them to the timestamp that God intended us to use, YYYMMDD, HHMMSS. And then I went into the feature writer and wrote out a parquet file for each one. And if I go and look, there you can see that I do have a number of different parquet files that were roughly, they were not roughly, they were exactly 10 seconds apart for each one. Parquet is a great file format for data streaming outputs because it's so good for high data volumes, and then you could maybe ferry each parquet file up to your data lake for other processing. So that's kind of my advanced example. Stuart, do you want to say anything about this one as we wrap up?
Yeah, this is my advanced example. So if you have a very, very high volume of stream, like thousands, because one engine can handle like thousands of messages every couple of seconds. So if you need to go higher than that and window across engines, then you can do that using FME server streams. So the thing to note here is, let's say you want to do an average speed for a vehicle in each window. You could calculate that per engine. You give them a window ID, and the window ID is the same across all the engines for each time period. So what that means is, after the processing comes out, you could store the average speed for each vehicle in a database for each window, and then you can do downstream processing. And what that means is it's kind of the MapReduce model. Yeah. For each engine, you might have 10,000 points every 10 seconds coming in, so 30,000 points. You're reducing the data down to, like, I don't know how many orders of magnitude less. You have a couple of values for each engine, then you can do another query. So in 2 steps, you can take data down from hundreds of thousands down to one value in the database.
Yeah, and then yes, so amazing. It's basically like Stuart was getting at, it's map reduce. So I think we're all done. We got all our demos done. So it's wrap up time. So just to, again, underline the highlights, we have all these connectors, we have spatial capabilities, you can scale it, and you don't have to write any code. And so you can get these solutions going very, very, very quickly. And we like to think we provide excellent value as well for your dollar. So give us a look at that site. If you want to dig in more and understand how to actually pull these things off, here's a couple links when you get these slides afterwards, or maybe Stephanie will chat these out now. You can follow the tutorials that Mark has put together with Stuart's help and work through all these. We're very excited to see FME being applied in this area, and we're even going to be more excited to watch and hear and see what all of you do with this in the weeks and months and years ahead. I just want to thank you all so much for tuning in today. Thanks, Stuart, for all the work you've put in. This was really kind of your vision, and it's been a journey to get here, but it's wonderful to see it all working together, and so excited about the future. So thanks so much, Stuart.
Yep, thanks everyone for listening. Yep, I hope to hear from you. As Dale said, when you look at those demos, as soon as you scratch your head, get into the live chat, and we will help you out because we want to learn with you on this as well.
So we'll head into the after party now. If folks have to leave, thanks so much for sticking it out. Look forward to hearing from you later. But if Mark wants to come on, or Stephanie, were there any questions we should address before we say goodbye?
Yes, we have a few great questions. The first one would be referring to the streams that we had in, let's say, the FME server playground. So what sets those streaming scenarios apart from what we have now with our new FME 2021 streams?
FME server playground, if I remember rightly, I think a lot of these are about streaming data out. So, you know, that would be batching a process that streamed data out. And this is about this as well, but this is more about ingesting large, high volumes of data, not pushing data out. You can push data out, but you know, none of those examples in the playground show you connecting to a sensor farm and reading, you know, hundreds of thousands of points a minute from a sensor farm. It's kind of a different scenario.
Mm-hmm.
I think, you know, the other thing as well is we saw with Pelmerex, you could do this before. Okay, yeah. So some of these demos in the playground, there was a way to do it. You had to set this custom parameter on server, and 1 or 2 transformers supported it, but it was very hard to use. And this is about, you know, making it much, much easier for all users to leverage this.
Mm-hmm.
Mm-hmm. Great. The next question would be, can you read from a SQL Server database as a stream, like a SCADA historian database?
Well, Carl always asks hard questions. Boy, I don't know how we would do that. I guess we just don't have experience with that. It's safe. If there's a way to do that with a select statement, then our standard SQL databases, our readers like our SQL Creator, for example, would work. So if there's a SQL interface to that would just keep going for eternity, then that would work. But I really don't know. And we may want to follow up with you, Carl, to find out more. Stuart, do you have any background in that?
I want to say if you're on Azure, maybe you could write a store procedure that pumps data to a some other endpoint within Azure that we can then consume, like Event Hub or something like that. But I have, as you say, I haven't ever run into that.
Yeah, good question. Got any
All
more
right,
for us?
and yeah, those are the big highlights. Is there anything else that you see that we should talk about?
There were a couple of folks that were asking about different kinds of outputs. One was asking for a Microsoft Teams connector, much as the Slack one, for those folks on the Microsoft stack. And so that's an interesting connector that we can put into the world of connector land and try to build. So thanks for that suggestion. The other one is writing to an Esri stream service. And I think, Stuart, the Esri Dev Summit is on this week, isn't it? And
yeah, we need to look into that.
Yeah.
I know they have streaming feature services now. They look very impressive, and I think I think they're based on WebSockets, and it's definitely something SAFE needs to look into.
Yes. When I was prepping for this, I did attempt to use ArcGIS Online, and actually I got it to work as an output, but it definitely wasn't as good as what their streaming service was. So that's why I didn't show it. And so you definitely, there's many different paths into the Esri world, but this one definitely looks like one that we need to be able to both read from as well as write to, I would say.
Mm-hmm.
So, I think, Mark, is that looking good from your side?
Yeah, looking good.
Okay.
Thanks.
Well, I think, Stephanie, are you going to give us permission to call her quits?
Permission granted. Great job, you guys. That was excellent. And thanks so much for all the good questions coming in. You guys kept Mark busy, and we hope that this gave you some good insight. And yeah, really enjoyed it today. So thanks so much too for all the comments earlier where people were saying how they want to use stream processing. It'll be fun, Dale and Stuart, for you guys to read after.
Great.
Thanks.
Cool. Okay, so I will close it down, but I'll leave it running for another 5 minutes if anyone wants to get in any last questions, or if you want to save out any links that we chatted. But thanks so much for attending today.
Goodbye, everybody.
All right.